code for deletion. Suppose, here how to this is a function which does a deletion operation. But if we want to how this function will be called inside a main function. Now suppose main function is written like that, int main, and here we have first array, and by insert operation we have the suppose array size is 5 or whatever. We have totally filled the array. Suppose the array is now totally full. Okay, suppose 10, 20, 30, 40 and 50. So 0, 1, 2, 3, 4, and this is array. It ordered that. Now front, this is front is pointing to this node, and rear is pointing to the last node, which is 4. Now we will delete. Now q is full, so we cannot insert anymore. Now we will start deletion. So here I will declare a suppose value where the deleted node will be stored. So value equals to, we will call the function del q, and here also I have to declare a front variable front. Then here initially they were -1. Okay, so in del q, how the function will be called, here is no space. So value equals to will be del q, this function is called, and what the parameter need to pass, base address of the array, which is arr, then the address of the front variable. So I have to pass address of variable front and the pdr pointer, that means which is the address of the rear variable. So address of rear. Then if we then print the value percentage d value, so it will print the extracted value, which is extracted from the front end of the queue. And now if we want to display the queue, the how it is now is, so for that we can just use the display function, which is already been described in my previous lectures while inserting item. After each insertion also will display this item. So again, if now after that the value will be the 10 will be printed because it was the first front node. Now front is pointing to next node 20. So again, if we call this function and like value equals to del q, then array address of front and address of rear, and if we print the value, printf percentage d and value, then the next front node is 20. So that 20 will be extracted. The value, this variable will contain value 20. Okay, so it will contain 20. So if we display the what is the q, what is the q, then it will be there. It will be now the q is, so the way the value in q is stored like that, 0, 0, 30, 40, 50. Then again, if we delete, now this is front and this is rear end. Okay, this is front and this is rear end. Now if we again we delete, then 30 will be deleted. So there we will put 0. Now front will point to this node. Again, if we delete, then 40 will be deleted and there will be 0. Now front will point to this node. Now after this, both there is only one item, that is a front. So what will be the q, how it will be displayed? It will be 0, 0, 0, 0, 40. But front and rear both are pointing to the same item, that is front value is 4, rear value is also 4. Now this is pointing, this both are pointing to this element in the array. Now if we delete this, then q will be empty and all of the location will be filled up by 0. But here is one problem. Problem is that after this we have done first insertion, then q gets filled totally, then we delete one by one. So after when the Q is like that. That is, it has reached to the it is now reached to the last index element. In that case, the front value is 4 and rear value is also 4. Now, if we want to insert a new value into this, that means we will call the function at q, where the base address of array to be passed. And suppose we want to insert 60, and also we are passing the address of the front and rear variable. You see, so in insert function, if you check the previous code, in insert add function, there was checking whether Q is full or not. The condition of Q is full or not was front equals to rear. Here front is equals to rear. Now front rear it is equal, okay, but front has got value 5. 5 means, that means it will this case on the front, when the front is 5 and the rear is also 4, not 5, 4, both value are 4. That is the maximum size of the array. So how to, in insertion operation we saw before, that if the rear value is equals to array size, maximum array size, then we find that q is 4. But here if you can see that rear value is maximum array size, but queue is not full because previous all the nodes, all the items have been deleted. After deletion, as the rear is also always pointing to the last element. Now, though it is the last index in that array, which is the maximum array size, still that queue is not full because previous all items have been deleted. So that is the disadvantages of representation of queue using array. In this case, if we want to insert 60, it cannot be inserted. It will say that Q is full because the rear has got the maximum array index. Though the Q is not full because before all of the items were deleted, there is space, but still it will be reported as Q is full. So this is the advantage of the Q representation using array. So how to overcome this limitation? So that we will discuss later. To overcome this limitation, we use a circular queue. So that will be discussed later, but this is the case. So this 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 is the case where front has becomes 4 and rear also becomes 4. Now this case is, this will be reported like this case 1, 10, 20, 30, 40, 50. That this rear value equals